这个例子啊。
对。
就不太懂它的 shift 的概念是与 origin 的关系吗？
By definition, for this one, if this center will be 0, right? Right. We didn't change anything. We didn't shift anything. But on the left is defined by -1. On the right will be +1. That's it. That's it. Okay. That's the reason. So it shift to the left, okay, by 1 pixel. So that's what we get. So this is the operation here. Actually, the dilation, if we shift this bi is the element. For this case here, we shift it by -1 to the left, and we to the right by 1 pixel. And then, because we're talking about the dilation, we're talking about the growth, right? So we take the unit. We take the unit. 我们做连级. We take the unit. So this part is to the left, this part to the right. Well, actually, as I mentioned, if I put the origin, define it also as H point, image point, then you will get a 3x3 square, okay? Which means this a thin line, a 3x3 thin line will be expanded to the left and to the right. That's it, okay? So you can think of here, if you take it as a 3x3, what would happen? A 3x3, what would happen? Each side will be to the left, to the right, to the top, and to the bottom. Everyone follow me? See that? Okay? Forget the set theory, okay? Not mathematically identical, but for implementation, here's my recommendation here. Just write this code. It say if f of x, y equal to 1, which means in a binary image, 1 means x, y is an object point, okay? If x, y is an object point. Then O is neighbor. The neighbor is defined by the structuring element. You will turn it into 1. No matter its neighbor pixel is 1 or 0. Everything, O is neighbor. Let me say it again. If xy is an object point, okay, then O is neighbor defined by B will turn into 1. If this neighbor point is also an object point, then you do nothing. But if it's a background point, then it will turn into an object point. That's implementation is so easy. This failed just for some structural element like this. It won't work. But as I mentioned, practically, we don't set up a structural element like this with the origin as a background point. No, usually we don't do something like that. Okay, we don't do it. Because for this case here, see that? Now for this one, usually we just want to expand in its neighborhood. But for this case, we just expand to the left, to the right, and the original object is gone. What is the purpose for that? No. Okay? 所以唯一在数学上，它不等，就只有你定义成这个样子才会。可是我说这个东西很怪，一般我讲没有人会这样做 ，because it will becomes two objects. No, we won't do that. Okay? So if you don't like the definition, well, this is the actual definition by by dilation. We do the translation, okay, for A with all the possible shift defined in the structural element. Okay, so A sub B is the translation for some element B. And after that, we take the union because we want to expand. So you need to take the union, okay? 所以我们做连结加强。But for programming code, this is something I suggest, just one single line. First you check, so for a binary image, you check XY, is a pixel point or not. If XY is an object point in the binary image, then all its neighbor defined by the structural element will turn into 1. That's it. And in this case, you know you will expand. And how it expands will determine by the structural element size or shape and also its origin, where you define the origin. That's it. Okay? That's it. 好，所以那个集合论那个看起来很复杂的话，就直接这样写就好。Okay? So here's another example here. Suppose this is B. Okay, this is another example here. Suppose we have a B like this. Okay. And this is the origin. Should be 0, and this will be 1. We shift to the right for 1. Okay. So this is A. This is A. Now we put the origin right here. We put it here. So you will expand to the right by 1 pixel, right? Right. See that? And then we put this origin at the second point here. Then you will also retain the original pixel and also you will expand it to the right. Now we put this origin right here. Okay, we will retain it because we take it as the origin. Then you will shift to the right. Now the right point is also an H point, pixel point. So we do nothing. Then we put this origin right here, starting from here. And we'll expand to the right. That's why we have 3. You have a 3 pixel right here. That's the reason. And lastly, we put this origin right here. Then you will retain the original pixel and also expand it to the right for 1 pixel. So this is the final object. Becomes here. Right? So that's it. Okay? Everyone follow me? Okay? And if you have a structural element like this, then this code works, right? See that? If SY is an object point, O is a neighbor, well, have the value of 1. No matter it's a background point or object point, just assign 1 to it, that's it. So it's very important how to define the structural element and how to define the center. But for most of the application, we simply put as a 3x3 or 5x5. A 3x3 or sometimes it's a cross hair. Okay, that's the most of the case. We'll do something like this. Okay, or for some case, we will go for, we use 2 structural elements, one horizontally, and the other one will be vertical. Okay, but this is the most of the case, 3x3 or across here. Okay, we'll do the expansion. Then you might do 5 by 5, but if you do the 3 by 3 twice, it will increment to 5 by 5 once. 你做2次3至3，你做 morphology, you can do the iteration for morphology for many times. But if the structural element is 3 by 3, if you go for the structural element 3 by 3 for 2 times, it's equivalent to 5 by 5 structural element once. Okay? And then if you do it one more time, then it will become 7 by 7. And then 9 by 9. And so, okay, so that's it, expansion, just expansion, to expand. Okay? So the idea is once a pixel is an object point or its neighbor defined by the structural element will have the value of 1. That's it. Okay? But mathematically, this is the definition, okay, by set theory. We do the translation for all the elements, and then we take the union. So that is span. And now you know what will it work for erosion. You will take intersection. 前面都做连接，你的 erosion because you want to shrink, you want to reduce, then you will take intersection. 一定要做交集。Okay, so I'll show you how we do it. Okay, so any questions so far for the dilation? Okay, dilation. See that if you apply the dilation with this rule or that algorithm, see that the skewness normalization. You see, we have a character like this one. Remember, after the transformation, you see there's a lot of white line here, right? Right? How to fill the white line? Then you just apply a 3 by 3. You apply a 3 by 3. Then all the white line will be filled with the object point, right? 记得吧？因为它那个名不是前面看的时候，它中间是白线吗？不，事实上不是白线啊，是背景。But we will go for the 3 by 3 expansion, then then it will be filled. It's not enough because it will go, so it will what? It will be 1 pixel expanded around the outer contour, right? And also the inner contour, right? Because it will expand. So it will fill the empty space, but also it will expand its size outward and inward. That's the reason why we need erosion. Then erosion will shrink. For this case, it will shrink. Then it will shrink with the same structural element B by B. Then we can reduce its expanded contour. But once the empty space is filled, even you reduce, there's no way you can reduce anything. It won't become an empty line again. That's the purpose for dilation and erosion. And that will be why we need opening and closing. And opening and closing is nothing but we do the dilation and then erosion. Or we can do the erosion first and then dilation. Okay? Why we need to do the erosion? For example, if you have something and you have got a lot of noise here, you are not going to apply dilation first. You will do erosion to reduce what? So that we can reduce the render noise. But at the meantime, the object will be shrinking. And then you need to apply dilation to make it grows back its original size. But once the noise is removed, once they are removed, there's no way we can put it back with dilation, right? That's the idea. So we need to interchange to use the dilation erosion if we want to maintain the original size. But we want to fill the empty space or we want to remove the noise. You need to determine what is your own purpose. So we need to go for the erosion and dilation. And there's a lot of different combination and you can do a lot of things. Even for the object detection. You can use morphology to identify a very specific object. And we can use this to identify, for example, if for this character meat, you can use morphology. Just find this so-called skeleton. You can find the skeleton of the object. 就是只留它的骨架，只留它的骨架。All this can be done by morphology, okay? By morphology. And with the basic operation, dilation and erosion. Okay, let's go for the erosion. Okay. Okay, then the erosion by definition. This is by definition, okay? A little bit weird. First, you need to define the structural element and define the origin. And then it's right here, okay? Now, for dilation, here, we take the union, right? We take the union of B. But for erosion, we go for minus B, minus B, and then we take the intersection, okay? We need to take minus B. But for dilation, we simply shift by B. But for this one, we shift by minus B, okay? Then we take the unit, okay? That's by definition. It means what? By definition, if X, I don't know why I change it to X, it got to be A, okay? Lowercase a plus B, okay? And then for every B that belong X, then X must be still belong to A, okay? Now, after the translation, the new locations must still a part of the original shape. Okay? Okay, now let me give you the example and I'll go back and show you how to do it in programming code. This is B, okay? This is the origin, this original image. Now we put this point right here. And then after the erosion, this point will be retained because this 2 point must be also a part of A. Now we put this point right here, it will be retained because O is neighbor still belong to A. And this is also true, but not this one. When we put this point right here, okay, that's enough. 假如我们把这个点放在这里 this point will become 1. This point will become 1. Because when we put it here, its neighbor is not an object point. Its neighbor is a background. So eventually we will remove this point. And also when we put B, the origin right here, because its right neighbor is a background point. So we will also remove this point, this point, this point, and this point. So what you got is just this 2 points. That's it. Okay? That's called erosion. But by definition, okay, if we go for this definition, this is A. Okay? This is A. Now, the first we do nothing, right? This original size. And then we need to put A minus 1, not 1, minus 1. So we shift it to the left, not to the right, because by definition, we shift it by minus B. Okay? We shift it to the left. And then we need to take the union, the intersection. 要交集. The intersection of A and A minus 1. So the intersection is only these 4 points. Okay? Everyone know one thing? Yeah. For programming implementation, just write this code. Now, if xy is an object point, then O is neighbor defined by the structural element B with this pi means the multiplication. 它的相乘, the multiplication must be also 1, which means O is neighbor. Any of its neighbor cannot be 0, cannot be background, right? It's supposed to, I define f of xy will be 1, okay, or 0, okay? Then this will be true, okay? If xy is an object point, now if it's background, it will be 0. So when we take the multiplication, which means any one of its neighbor is 0, then the outcome cannot be 1. That's it. 也就是说，它所有的 neighbor 每一个人呢都要是物体的一部分 ，which means whenever we check an object point as y, we need to make sure all its neighbor is also a part of the object. Okay, so that in that case, then we can reduce, we can erode. So in this case here, as I just mentioned, if you have something here, right, and you have a random noise, then it's quite easy when we put it here. If this random noise, this single point is all its neighbor, its background, then we will remove this point and this point and this point. But the outer contour will be reduced, right? Will be reduced by 1 pixel for a 3x3. So in that case, you want to make sure you will retain the original shape of the object. Then after erosion, you need to go for dilation one more time, okay? And put it back. But once the noise is gone, even you apply the dilation, what noise is gone, okay? Right? 因为杂讯已经移掉了，你再怎么放它也回不来。So sometimes we need to do the dilation first, then erosion, or sometimes we need to. So the purpose is if you want to fill, okay, some empty space, then you go for the dilation first, then erosion to move back the original size. If we want to remove the noise first, then you apply erosion first, and then dilation to growth back its original size. But at the meantime, you have already removed the noise, okay? So if you don't like too much about the definition by set theory, just go for this line, that'll be fine, okay? But the first you have to make sure your binary image is something like this, okay? Your background is 0, okay? Then that'll be fine, okay? So that's for erosion. Okay, and this show you why this definition is work. Okay, it got to be minus b, but not b. Okay, minus b, and then we take the intersection. Now here, so based on that, then we have 2 more. Okay. Operation. opening. Okay. The notation is just a small circle, okay, an empty circle, okay, which means we take the erosion first, okay, erosion first, and then we go for the dilation with the same structuring element, okay? We use the same structuring element. We do the erosion first and then dilation. That's so-called opening. Now, the purpose for that usually is to try to remove the noise, okay? Remove the noise. Or if you, from your assignment number 1, where you do the binary slash holding, after you do something, you might have some noise peak right here. Then usually we want not just to remove the noise, you want to remove the small peak here. Then you can apply erosion, try to remove it. Yeah. Okay, and then you will also reduce its contour so that we need to do the dilation one more time to bring it back to its original shape. However, the small peak will be gone. Okay, that's the purpose for opening. Okay, so we do the erosion and followed by a dilation. So we remove too small. Okay, we remove all the pixels in a not too small to contain B. Okay. Now, the other operation is called closing. The notation is you just use a solid, okay, a solid circle, which you do the reverse way, which means we go for the dilation first, and then erosion with the same structuring element. Okay, so we go for the dilation. Try to fill some empty space, and then we do the erosion to bring back its original size. Okay, so you have no idea at all. Usually, we simply just apply a 3x3. As I mentioned, you apply 3x3 structural element twice equivalent to 5x5. Okay, once. And then we do it one more time, then we'll equivalent to 7x7. Okay, so that's it. Okay, so for this one, you try to fill empty space or a small hole or concavity. Okay, the concavity. So that's smaller than B. So we do the anyway. Okay, any questions so far? So it's very useful tool, okay, especially after you do some thresholding or you use a deep learning model for segmentation, okay? After that, you can apply erosion, dilation or opening, closing to remove the noise and fill some empty space or small crack, okay? So that's the purpose. And the following, just give you more example. This is the original size, okay, object. And this is the structural element, okay? It defines the center, the origin right here, okay? It's the structural element B, okay, B. So it should just show you the difference, how it works for dilation, okay? So you can just look for yourself, okay? This is for dilation. So after that, you see the original, you can see there's a gap here, right? And because this is the size, okay? The size is 3, okay? Horizontally. So because the width for the gap is only 2, right? It's only 2. So but the gap here is 3. So it won't. So after the dilation, then you will have something like this. It will fill the gap, but it will still maintain. Okay. This, okay, the shape here. Okay. Then why is empty? Why is empty? So why the corner is not filled? See that? The corner is filled. That's because you use this structural element. So there's no way you can fill it. Okay? So, but if you want, you can use something like this, the before. Then you will fill this empty space. Or you can do something like that. Then you will fill. So this corner will be filled. And also this 2 point will be filled. Okay? But it will expand what? Upward. Right? The object will expand upward. 它会往上膨胀. But it won't go downward because we have nothing here compared with the origin. Okay? So this is dilation. What about the erosion? See that? After the erosion, okay, the object is separated into 2 independent objects. Okay? After that, this. Okay? 好，它被拆成2个物体。好 ，this is erosion. Okay, this is the result of erosion. Okay. Then we can apply the opening. Okay, we can do the erosion and then dilation. This is the erosion, and then we go for the dilation. After that, there's something you might want to remove the leg or something. I don't know, depends on your application. But for this case, see that the leg here is gone. Okay, but it can still retain the gap. Okay, this is the opening, and this is the closing. Okay, the closing is we do the dilation first to fill the gap, and then we do the erosion. See that? And then we fill the gap and try to maintain the original size, but these 2 points cannot be filled. That's, as I mentioned, that's because you have the structural element, okay, like this. So the 2 corners, the outer corner will be gone, okay, eventually, right here. There's no way you can fill it unless you do something as I just suggest. Go for it like this, okay? But anyway, finally, we maintain most of the size, but fill the gap, okay? But fill the gap. This is for closing, okay? So we after the class, you can when you go through the class material, you can check for you by yourself, okay? How it works with the structural element, okay? To make sure you work. Here's another good example. We have a random line 7 in the background with some circle, okay, with some circle. So for this application, what should you do to remove the random line 7? You need to do what? Opening or closing? You got to
closing.
Right. No. Okay. Closing then what? Because it is span. It's span.
I'm sorry. Opening first.
Right. Opening first. But you need some prior knowledge to design the structural element. How the structural element should look like. so that you won't remove the circular object. So the B should be less than the size of the circular object. You know what I'm saying? I mean, if the structural element is too large, then everything will be gone. Not just the line 7, but also the circular object will be gone. So you have to make sure the structural element is smaller than the object, but got to be larger than the line 7, the width. So that's why I'm saying that's one of the problems when you apply the morphology. You need some prior knowledge. You need to know something about the object that you are going to use. If you have no idea at all, then you cannot reach your goal for this case to remove the line here, okay? So if you have a structural element smaller than the radius of the circular object, then it's quite easy for you to remove the random segment. And then we put it back. We put the circular object back, because after that, this circular object could be just one single pixel left. It could happen, right? But it doesn't matter. If you apply the same structural element B again, then everything will grow back to its original size. But at the same time, all the random line 7 has been removed, okay? So it explains something here. It's supposed to say that the disk or the circular object have the diameter of 35 pixels. You need to know something. And now it uses the structural element that having the diameter of 13. It does not have to be 13, 12, could be 5, or as long as it's less than 35, that'd be fine, okay? But for this case, you demonstrate with a diameter of 13. So what I'm trying to say, no matter what, you need some prior knowledge. What are you going to remove, or what are you going to fill, so that you can design a good or appropriate structural element. The size, the shape, right? For this case, you got to know. You got to know the object diameter is 35 or around 35. But anyway, the diameter, it takes 13 or 12. I think it should be fine. But in that case, all the random line 7 will be removed. Okay? 就是说在使用上，你还是需要一些事先知道的东西，不然你也不知道怎么设计啊。那是在应用上 ，and that's why we call it morphology. Finally, that's because you have changed it. You do something based on B. You can use the B to change or to set up a new morphology. That's why you use the name morphology 形态，它改变它的形态，是这样 ，OK? Based on the structural element B. Okay? Here is another example. Here, visually, it tells us we have 1, 2, 3, 4, 5. We have a 5 cluster, right? We have a 5 cluster. This definitely we need to apply what? Close. Expand. We need to expand, right? So that we can fill this space. For the object point that belong to the same cluster. So for this application, what knowledge you need to know to set up the good structural element, or you need some what assumption. But first, you have to make sure all the neighboring points that belong to the same cluster, the distance should be less than the closest distance between different clusters. Otherwise, they will be connected. for me, for this example, I didn't try it, but they seem so close. I mean, compared with some pixel location around here. I don't know. They might connect, right?
Yeah. Oh, I was saw a video about this. It's similar. They call K-mean clustering.
No, there's nothing with. Right, you can apply this for.
Find the cluster.
But K-mean cluster is not for this morphology. We can only. No, I didn't say that you can only apply for two-dimensional space. Actually, it can be three-dimensional, but not something. But K-mean is a machine learning algorithm. Minship can do the clustering. Minship can also do the clustering. It does nothing to do with. But when we talk about the morphology, usually we talk about the image. We don't. K-mean will be another topic for the courses I offer next semester. Okay. Anyway, but that's the idea. Anyway, you know, as it mentioned here, you got to know something. You say all the neighboring point that belong to the same class, they have a distance less than rho 0, and then the distance between different classes should be at least 2 rho. You need to know something like this. Otherwise, you will put the different clusters together. You need this assumption. Okay? Otherwise, it won't work. Okay? But for humans' eyes, visually, we know this got to be a cluster. This is another cluster. We don't need to measure what should be the distance between the neighboring point or neighboring point, right? We might have some doubt about this 3 point, but I don't know. For some, if you don't set up the beat good enough, then maybe you will connect this cluster with the pixel point in this cluster. So that's one thing. You need some prior knowledge to make it work. Okay, you do need some assumption, but other than that, I mean, morphology is a good pre-processing or post-processing tool, okay? Especially when you apply thresholding. After the thresholding is good enough. You don't need to worry about the noise in the binary image. You don't worry about some of the missing hole or do something wrong, okay? So that will be. Okay. So I still have a couple of minutes. Let me just show you some good application. You can extract the boundary. Okay, you can extract the boundary. What can we do? A is the original object, binary object. First, we do the erosion. Then you will straight, right? You will straight the outer space, the outer contour. Then we subtract the original image, okay, from the erosion result. Then what is left? There will be the contour. But it does not mean you have the, remember I mentioned about the boundary following, remember, for boundary or contour tracking, it means PI and PI plus 1, they must be connected. Now, this won't give you that information, okay? It will show you the outer boundary, but it won't say PI and PI plus 1, they are connected, they are A connected. 记得网上不是讲过，一定要确定它的每一个点 ，right? Especially you want to, if you have an object like this, we need all the point, okay, here so that you can fit it into a line. But for this case, we just know, okay, if this is the object, then we use a 3x3, then we do the erosion, then it will be straight, right? It will be straight. For all the outer contour, okay, the contour will be gone. So we A minus this part, okay, which is the inside pixel of the object. What is retained will be the contour or the boundary, but they are not, you have no information about this, okay? Okay, you have no information for this at all, okay? So if we want to do, especially for line fitting or circle fitting, you still need to go back to apply the boundary following or contour tracking. Okay, but there's one of the application you can find the contour. You can find the contour of the object by this simple operation here. Okay, A minus the erosion. Okay, and with a simple 3x3. Okay, with the origin at the center. Okay. I just put a note here. If you go for the dilation and minus A, then it's still a contour, but this contour not a part of the object. It will be the outer contour. You know what I'm saying? 因为你这样做 so this contour is still a part of the original image. But if you go for the dilation and subtract it, okay, with the original image, then this boundary will be the outer boundary, okay, will be the outer boundary, but not a part of A, okay, so it depends on how you do the operation, okay. It can also apply for region filling, okay. Let's just stop here today, okay? All others will be just it needs some iteration, okay? Starting from original size, we do the erosion, then we take the intersection of AC. ACC means complement. The complement of A means what? If take XAC means if A equal to 1, now this AC complement will become 0. 0 will become 1, 1 becomes 0. That's it, okay? An object point becomes a background point, a background point will becomes an object point, so-called the complement, okay? So you just do some set operation, and then you can do a lot of things, okay? For region filling, can do a lot of things. And next week, I will talk about how to use morphology for ground level. Okay, for ground level image is very important, even as a pre-processing, post-processing. Okay, so we stop here, then and work on your assignment number 2. Okay. Okay, so see you next week. 你们有问题要问我，要赶快哦。